This is a lecture for The Living Earth, Unit 1.1. The topic is Earth's spheres. Earth's spheres. This topic will be broken up into a few different videos to make the size of the individual lectures a little bit more manageable. But we are going to be building towards the essential question: what are the major components of the Earth system? Your essential question is: what are the major components of the Earth system? Our first main idea is going to be that the Earth has many spheres. Many spheres. Earth can be divided into various spheres that describe the Earth's land, water, air, and life. The geosphere describes the solid exterior and interior of the planet. The hydrosphere consists of all the water on the planet's surface, including the oceans, lakes, ice, and rivers, as well as the moisture in the air. The atmosphere consists of the ocean of air that surrounds the surface of the planet. The fourth sphere, which is called the biosphere, consists of all life on Earth. The spheres of Earth are all interdependent. This means that they support one another. Energy and mass move among the various spheres in an attempt to establish and maintain states of equilibrium. The carbon cycle is an example of the interaction between spheres. The biosphere is heavily dependent on the presence of carbon to support and sustain life. At the same time, much of the geosphere is composed of carbonate rocks and minerals, which accumulate in the oceans, which is part of the hydrosphere. Other cycles, which operate similar to the carbon cycle, include the water cycle, the nitrogen cycle, and the phosphorus cycle. Energy is distributed around the Earth continuously when heat is transferred between the atmosphere, the hydrosphere, the geosphere, and the biosphere under the influence of the global circulation system. So the first sphere that we are going to look at in detail is the geosphere. So our next main idea is going to be the geosphere. The geosphere consists of Earth's core, mantle, and crust. The core is divided into two sections. The solid inner core has a radius of about 1,200 kilometers. The liquid outer core, which is 2,250 kilometers thick, surrounds the inner core. And at 2,900 kilometers, the mantle is the thickest region of the planet. And the mantle is divided into three sections. The mesosphere. Sorry, I got ahead of myself right there. The mesosphere, the asthenosphere, and the lithosphere. Now, the rigid upper mantle directly beneath the crust, right? The upper mantle and the crust together are referred to as the lithosphere. Lithosphere. So we have the mesosphere, asthenosphere, and lithosphere. The solid exterior of the planet is called the crust. The crust is composed of rocks and minerals dominated by 8 elements. Oxygen coming in at 46.6%, silicon coming in at 27.72%, aluminum coming in at 8.13%, iron at 5%, calcium at 3.63%, sodium at 2.83%, potassium at 2.70%, and magnesium coming in at 2.09%. Earth's crust is classified as oceanic crust or continental crust based on each one's composition of rocks and minerals. The composition of oceanic crust is primarily iron and magnesium silicate minerals. It is 4 to 6 kilometers thick, but is very dense. Conversely, continental crust is 30 to 70 kilometers thick and composed primarily of aluminum silicate minerals. Because oceanic crust is denser, it sinks beneath continental crust at locations where they come together. The crust and the uppermost part of the mantle form the lithosphere, like we mentioned earlier, which moves across the planet's surface in large sections called plates. Our next main idea: geothermal gradient. Geothermal gradient. The temperature of Earth's interior is not constant. The geothermal gradient describes how the temperature increases with depth beneath Earth's surface. This steady increase, as you go down, is caused by the release of residual heat from when the planet formed. For every kilometer in Earth's crustal interior, the temperature increases by 25 degrees Celsius. Temperatures in Earth's mantle and core level off. The core is thought to be about 5,000 degrees Celsius. With this information, scientists performed a number of laboratory experiments to determine the temperature and pressure conditions necessary to produce the rock fragments brought to Earth's surface during volcanic eruptions. These experiments suggested that Earth's interior is an environment of intense pressure and temperature. They also discovered that the chemical composition of the rock on the outer surface of Earth differs significantly from the composition of materials found deep within the planet, meaning the outer portion of the planet is very different from the inner portion of the planet. That's going to be it for this lecture. We will continue to build on this essential question: what are the major components of the Earth system? Again, there are more spheres to go, but we are building an answer to the essential question: what are the major components of the Earth system?